Let's look at the second half of 8.2.2. All right, we're going after, excuse me, we're going after a triangle here. I have the base, I need the height. I know the area of a triangle. The area equals base times height divided by 2. If you want to use the formula perimeter times apothem divided by 2, you absolutely can. It will get you the same idea. Let's go ahead and draw our height down this line. I know that all three angles of a triangle has to add to 180 degrees, and I know that these are congruent because this is a regular or equilateral triangle. That means that each of these must be 60 degrees. That means that if I used this triangle here and used a right triangle, I have this base length of not 5, but I'm using half of it, which is 2.5 centimeters, and I know that this angle is 60 degrees. That means that this angle must be 30 degrees. Oh, we have a 30, 60, 90 right triangle. To find the apothem, I need to take this number and get it to here. You can either use trigonometry or you can use your special right triangle rules. I know that this represents the x in my special right triangle rules, right? If this is my 30, then I have x, and I have x root 3, and I have 2x. So to go from the side across from 30 to this side, I times by root 3. So to go from here to here, I need to times by root 3. So I'm going to take 2.5 and I'm going to times it by root 3. Since this question asks for it rounded to the nearest tenth, I'm actually going to type this into my calculator. And I get this decimal version of this answer, which is about 4.3301. All right, so we have found, we already know the base is 5, and we know the height, we just found that, is this number. So we are ready for our answer. To find the area, we're going to do the base length of 5 times the height, which is 4.3301, and divide that answer by 2. So if I times, again, I still have this number on my calculator, so if I just say times by 5 and then enter, and then I press divide by 2, I get an area of about 10.8 when I round to the nearest tenth. This is in centimeters squared, and there you have it. Number 6, don't get tricked. Number 6 is like the easiest problem ever. Think about it. By the directions, this is a regular polygon, so that means all 4 of these sides are congruent. So this thing must be a square. So do you know how to find the area of a square? Isn't it base times height? So if this is 5, this has to be 5. So isn't it just 5 times 5 is 25 miles squared? If you wanted to, you could go through the whole apothem times perimeter divided by 2 baloney, but you're going to get the same answer, and this is so much easier. Don't be tricked. This is a simple problem disguised as a hard one. Let's look at number 7. Okay, I have a hexagon, so I have 6 sides. I'm going to go after this using area equals apothem times perimeter divided by 2. We know the perimeter already. The perimeter equals 24, so we just need to know the apothem, and we can go ahead and solve for our answer. I know that all 6 angles of a hexagon have to add to 720 degrees, so I know that one angle by itself, 720 divided by 6, is 120 degrees. That means that if I put my little triangle in coming from the center, I'm only using this portion of that red angle, so I must only be using half, which is 60 degrees. Dropping down my apothem, I'm going to do it in blue here. I can find the apothem by using this right triangle. Let's go ahead and draw that again. Here's that right triangle. I've got a 60. I'm looking for my apothem, and I know I have a 60-degree angle. I forgot to write that in. Last but not least, I know these side lengths. All 6 of them add together to give me 24. So to find just one of the side lengths, I'd do 24 divided by 6. to get 4. So the entire side length here is 4. Then what then is just this little half of it? That must be 2. Because remember, it's only using half of the picture, half of the base. Now then, you can go ahead and use your special right triangle rules if you'd like, because this is a 30, 60, 90. So to move from this side to this side, we times by root 3. So that means this would be 2 root 3. If I type that into my calculator, 2 times the square root of 3 is about 3.4641. Hey guys, we just found the apothem. It's about 3.4641. I'm going to leave this number on my calculator because my next step here is to do the perimeter times that number, 3.4641, and I'm leaving it on my calculator, and then I'm going to divide that by 2. So since this is already on my calculator screen, all I have to do is say times by 24, times by the perimeter. I press enter, I get something around 83, but then I have to divide that 83 number by 2, and I press enter again, and I don't have to do any rounding until the very last step, and I get rounded to the nearest tenth, 41.6 feet squared. The next one, how many sides is this? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is an 11 gon. Okay. So I'm still going to do my normal idea where the area equals the apothem times the perimeter divided by 2. I know the perimeter is 88. So since this is an 11 gon and all sides are the same, that means that this side must be 8, right? Okay, let's figure out how many angles is within an 11 gon. I know that the sum of the angles must equal 180 times n minus 2. Well, n in this case is 11. So 11 minus 2 gives me 9. If I do 180 times 9, I know how many degrees is in this entire shape. It's 1,620. So that's all of these 11 angles added together. So to get just one of those angles, I'll divide that answer by 11. And now I know that this angle, the entire thing, is somewhere close to, and this is a decimal, so I'm rounding, 147.27 degrees. Okay, well remember, I'm going to be using an isosceles triangle here to find the apothem. You can see that I'm only using half of that angle, so I'm going to take this number and divide it by 2, and I get that blue piece of that angle is actually, the piece I'm going to use is 73.6 degrees. Okay, from this point I think I'm going to draw this picture again. Let's drop down our apothem so we can know what we're solving for. Remember, we're looking for the apothem here. So if I drop that down the middle, I create this nice skinny right triangle. Let me draw that skinny right triangle again for us, and we can maybe make it a little bit bigger so we can see here. Again, I have that blue angle here is about 73.64 or something like that, 64 degrees. And I know that this base length, the entire base is 8. So the half of the base that we're using in this picture is 4. And we are trying to find the apothem. Once we have the apothem, we have our second piece of our formula and we'll be ready to solve. So I've got all of these pieces. Let's go ahead and use trigonometry. I've got this side. I have information about my opposite and my adjacent. So I think tangent is a good idea here. The tangent of an angle, in general, the tangent of an angle equals the opposite side over the adjacent side. So the tangent of this angle, which is 73.64 degrees, equals the opposite side, which is x, over the adjacent side, which is 4. To get that x by itself, I'll times both sides by 4. And I get that x equals 4 times the tangent of 73.64. I'll type that into my calculator exactly as written, and I get that x is somewhere close to 13.6227. Okay, so you guys, we just found the apothem. This is the apothem, what we just found, the x. So now we know what our apothem is. It's about 13. So we're ready to go after our overall answer using that original formula, apothem times perimeter divided by 2. Remember, our apothem is 13.6227. We're going to times that by our perimeter of 88, and we're going to divide that by 2. So if I do that in my calculator, I get that this 11 gone is about 599.4 kilometers squared. So if you get something close to 600 kilometers squared, then you have this answer correct. Okay, number 9 looks like we have an octagon. So I see that we have 6 congruent sides. So if the area equals the apothem times the perimeter divided by 2, I know that that perimeter must be, I have 8 equal sides and they're all 6 miles long. So that perimeter must be 6 times 8, which is 48. And then we'll just need to find our apothem, and then we can go ahead and solve this problem. So let's think about an octagon. What do all of these angles have to add up to be? Well, I know that the sum of the angles equals 180 times n minus 2, and n is the number of sides. Since n is 8 in this octagon, I'm really doing 180 times 6. So that gives me 1,080 degrees within this octagon. So to find one angle individually, I would divide that by the 8 equal angles, and I know that this entire thing is 135 degrees. However, that's still not the angle I want, because if I draw my radii in and create this isosceles triangle, remember you're only actually working with half of that 135 degree angle. So if I divide 135 by 2, I get that the purple angle that we're actually using is 67.5 degrees. Next, remember the whole point of this is to find the apothem. So if I draw my apothem, this blue line in, you've just created a right triangle. If I redraw that right triangle, which I like to do just to stay neat, I know that the angle I'm working with is 67.5 degrees. I also know that I'm looking for this. This is my end goal, to get that apothem. And finally, I know the entire base length is 6 miles long. So the half that I'm using would have to be 3 miles long. So I think we can go ahead and use some trigonometry here. Again, I have my opposite and my adjacent sides, so I think that tangent would be a good option. The tangent of an angle equals the opposite side over the adjacent side. So the tangent of this angle, which is 67.5 degrees, must equal the opposite, which is x, over the adjacent, which is 3. To get that x by itself, I need to do the opposite of divide by 3, which is times by 3. That way, our 3's will cancel on the right-hand side, leaving us x by itself, and then 3 times the tangent of 67.5 on the left. So if I type that into my calculator exactly as written, I find that x, or the apothem, is 7.2426. Okay, so we just found the apothem, which means we can plug that into our formula and solve for our overall answer. So our formula says take the apothem, which is that 7.2426 thing, we times it by the perimeter, which is 48, and then we divide that answer by 2. If I type that into my calculator and round to the nearest tenth, I get that my answer is 173.8 miles squared. So if you get somewhere close to 173, you know that you have this correct. Last but not least, we're working with a 7-sided figure. To find the angles of a 7-sided figure, I would do 180 times n minus 2. So in this case, that n is a 7, so I do 180 times 5. I know all of those angles in there have to add to 900. To get one of those angles by itself, I divide it by 7, and I know that one of these angles, the entire thing, is about 128.57 degrees. Remember, I'm not going to use that entire angle though, because now once I put in my triangle, because I want to go after my apothem, I am only going to be using this half of that angle. So if I divide that base angle by half, the angle I'm actually going to be using to solve with this problem is 64.2857 degrees. Now, the whole point in doing that is to find our apothem, because the overall formula for a regular polygon, the area equals the perimeter times the apothem divided by 2. Well, the apothem is that line that makes this triangle a right triangle. So we can use our knowledge about right triangles and trigonometry to solve for it. I already know, or I'm very close to knowing, what the perimeter is. The perimeter is going to be 4 times how many sides there are. There are 7 sides, so 4 times 7, or 28 for the perimeter. I just need to know the apothem, and then I can solve this overall problem. Let's use this right triangle to solve for the apothem. I'll draw it again so we have a better idea of what this looks like, and I'll try to make it a little bit bigger so we can see it easier. I know that this angle right here is 64.2857 degrees. I also know that this side length, the entire length across here, is 4, but we are only using half the length, so this length must be 2. Finally, remember that if we find this blue line, our apothem, we basically have all the information we need to solve for this problem. So let's go ahead and use trigonometry to solve. I have this angle. I have information about the opposite side and the adjacent side. So tangent will help us solve this. The tangent of an angle equals the opposite side over the adjacent side. So the tangent of this angle, which is 64.2857, will equal the opposite of x over the adjacent, which is 2. I want to get my x by itself, so I need to do the opposite of divide by 2, which is times by 2. That will get the x by itself on the right-hand side, and then that equals 2 times the tangent of this big, huge decimal. So I can go ahead and use my calculator and type that in. 2 times the tangent of 64 point blah, 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 equals, I get x to be equal to something close to 4.153. This represents my apothem. We just found the apothem to be 4.153 about. Now we have all the pieces we need to solve for the area. The area is going to be the perimeter, which is 28, times the apothem, which is 4.153, and then divide that whole answer by 2. So if I times my answer by 28, divide it by 2, I get that the area of this 7-sided shape is about 58.1 meters squared.